Assalamualaikum. My name is Habibullah, 21TE79. Today we discussing lab number 7 of digital signal processing. In lab 7, we discuss frequency analysis of digital sequences. Now moving towards lab objective. Lab objective is to study digital sequence in terms of frequency spectrum, and second one is contribution of high frequencies in a sequence and contribution of low frequencies in a sequence. Now moving towards task of this lab. So in task 1, consider the following sequence: x is equal to 1, 2, minus 1, 1, minus 2, 0, 2, 3. Plot the signal in MATLAB octave. If sampling frequency is 20k sampler per second, then first redraw the sequence after removing frequencies above 5 kHz. Observe and discuss the effects of this removal of frequencies. The second one is redraw the sequence after removing frequencies above 7 kHz. Observe and discuss the effects of the removal of frequencies. Now moving towards MATLAB to run this task. Now this x is given in the lab manual. So 1, 2, minus 1, 1, minus 2, 0, 2, 3. Now the sampling frequency is 20k, sampling frequency in hertz, and t is length of this. Then we plot the t and x, and in x level we give the time, and in y we define the amplitude, and in title we define original signal. Then the second part of this task, so cutoff frequency is 5 kilohertz, and the normalized cutoff which is we defined by a formula fc over fc divided by 2. Then after this, design the low pass filter and apply the filter to the signal. Then plot the filter signal. In x level we define a time, and in y level we define amplitude, and title we define signal with frequencies less than 5 kilohertz. And moving towards the third part of this task, so cutoff frequency in hertz is 7 kilohertz, and normalized cutoff frequency which was finding by this formula, and then design a low pass filter and apply the filter to the signal. Then plot the filter signal. In x level we define a time, and in y level we define amplitude, and title we define original signal which was original frequency which was less than 7 kilohertz. Mm, so then we going to run this task. So this was the original signal, the first one, and this was the signal frequencies which is less than 5 kilohertz as we see in the graph, and this was the third which was less than 7 kilohertz signal with frequencies. Now moving towards task 2, use the following audio which was given in as a audio, and then this audio we calculate the DFT, and then remove the upper half of frequencies, uh, i.e. frequencies about simple frequency divided by 4, and observe the changes by listening the audio. Then the third task is remove the lower half frequencies below f simply frequency divided by 4, and observe the changes by listening the audio. Now moving towards MATLAB. First we cut all these. So this was the first task. First we define audio read, which was given music, we are save in the MATLAB drive. Then for sound we use sound, and then calculate the DFT using FFT. Then obtain the frequency axis by plotting. N is equal to length, we use N for length, and F for 0 to N minus 1 for frequency axis. Then plot the magnitude spectrum. Plot then x level in x level we define frequency in hertz, And in Y label we define magnitude, and in title we define DFT of audio sequences. I'm moving to run this task. It takes few seconds. So this was the output of the DFT of audio sequences. Now moving towards second task, part B. This was the audio which was given in the lab manual. Now we find the index corresponding to simple frequency divided by 4, then 0, then 0 out the upper half of the DFT coefficient, and we will construct the audio sequence using inverse DFT IFFT, and then play the modified audio. I'm moving toward run this task. So this was the second one. I'm moving toward third part of this task. As we know, this was given in the lab manual, which we save in the MATLAB drive. Then calculate the DFT using FFT. For this we use DFT is equal to FFT into Y. Then obtain the frequency axis for plotting. N we use for length in Y, and F we use for frequency axis. Then 0, 0 the lower half of the DFT coefficient, DFT 1 to index equal to 0. Then reconstruct the audio signal using the inverse DFT IFFT modified signal equal to IFFT DFT. Then pair the modified audio signal. I'm going to run this task also. This was the third task we could perform in MATLAB already. Thank you for watching.